Assalamualaikum.
Walaikum assalam. Okay, guys, look at the question. This is of conversion of the binomial with the normal distributions. So look, in a certain country, 60% of the mobile phones are sold by company A. 35% are made. Sorry, 60% are made by company A. 35% are made by company B, and 5% are made by other companies. Find the probability that out of random sample of 13 people, so it means कि n is given. When n is given, it means this is leading to your binomial distribution. N is given, and fewer than who buy a mobile phone, fewer than 11 chosen a mobile phone made by company A. So we are focusing on company A, and number of trials. N means number of trials. If number of trials are given, look, if number of trials are given, it means n equals 13, and the company A is making 60% mobiles. So P is the probability of getting some event that is success. Phone is made by company A. So you can write the phone is made by company A. So that is 60%. So it means 60%, which is actually 0.6. This is P. So what is your Q? Your Q mean mobile is not made by company A. Phone is not made by company A, and that event is considered to be Q. If P, mobile phone is made by company A, is P, and that is 60%, which is 0.6, so that would be 0.4. So Q would be 0.4. If your P is the probability that the phone is made by company A, that is 60%, which means that is 0.6. And when you have these three things in your question, the N, the number of trials, the P, probability of some event means success, and Q, and these three are constant. This is a definite hint that it is a binomial distribution. So you can say here x is distributed binomially. X is distributed binomially where here you can write your n and p. So this is a standard way to tell the examiner that this x, the data, is being distributed binomially. In some other question, this x will be distributed like geometrically in geometric distribution, and it can be your normal distribution as well. So when you have a connection with binomial with normal, you need to convert your binomial distribution with the normal distribution. That is the most and harder level to convert this thing. So x is distributed normally, so I have information my x is distributed binomially, and n is number of trial 13. Find the probability that out of random sample of 13 people, so my n is 13 and my probability is 0.6. So this is 0.6. Now a fewer than 11, look, a fewer than 11 choose a mobile phone made by company A. A fewer than means you are supposed to get your probability of x which is less than 11. Now what will you do? There are total 13 trials and the examiner is asking you to get the probabilities fewer than 11. Fewer than 11 means you are supposed to get the probability of 10, the probability of 9, the probability of 8, 7, 6, 5, 4, 3, 2 and 1. This is a very time consuming process. So what is the smarter way to get rid of this problem? Are you going to get, I told you earlier, when there are probabilities more than 3, then it is a higher level of stupidity if you are going to engage yourself to get all those probabilities. Examiner will laugh on our stupidity ke we are wasting our time. So what is the smarter approach to get the probabilities lesser than 11? There are total 13 trials. So the total sum of the probabilities is 1. So what is a smarter way that is coming in your mind? That is, if I subtract from 1 the probabilities of 11, 12 and 13 from 1, then I will be getting all those probabilities that are considered to be less than 11. Look, if I am going to get this thing, probabilities of x, and x equals 11, I am telling the examiner my thinking process, my approach. Then I will calculate the probability of 12,
5,
and
11, 12, 13.
then great, 11, 12 and 13. So if this is my spotter approach, examiner is asking you to get the probabilities below the 11. So it means that these are 10 probabilities you are supposed to calculate, but that is not a sagacious approach to do that level of hard work. So just get these 3 probabilities, and look, I'm doing this thing.
Voice is lagging.
What? What are you saying? Can you hear me properly?
Have you